Okay, we're on chapter 9, lesson 7, and we are subtracting mixed numbers now. I'm on page 599. And we're going to use equivalent fractions to subtract mixed numbers. And I'm going to go through the examples on this one to show you the way the book suggests doing it, and then I'm going to use some paper over here and show you another way you can do these, still with equivalent fractions. Olivia had 4 3/4 boxes of games. She gave 1 1/4 of the boxes to her brother. How many boxes of games does she have left? So we're finding, since she gave boxes to her brother, we know it's subtracting because she gave them away. So we have 4 3/4 minus 1 1/4. So we're writing each mixed number as an equivalent improper fraction. So we separated out 4 into 1 plus 1 plus 1 plus 1, which is also 4/4 plus 4/4 plus 4/4 plus 4/4. And then the 3/4 was part of the fraction to begin with. Now we've got 4, 8, 12, 16, 16, 17, 18, 19. So my numerator is going to be 19, if the pen will write. Not very well. 1, 9, come on, you can do it. There we go. And 4 is my denominator for all. I've got 1 1/4. The 1 can also be written as 4/4, and our 1/4 is here. So I've got 4 plus 1, which is 5/4. It looks like 6, but trust me, that's a 5. Okay, so then we're subtracting 19/4. Take away 5/4, which is what they've shown here. 19 minus 5 is 14/4. And now, since they just magically showed you 3 2/4, I'm going to show you what they're doing to go from 14/4 to 3 3/4. So we've got 14/4. One way to do this is to divide, and I've showed you that. Box top number goes in the box, bottom number goes outside. You can write your multiples 4, 8, 12, 16, 20, 24. And 4 doesn't go evenly into 14, it would be in between here, so we have to go up. That's 1, 2, 3 jumps down. So 4 times 3 is 12. That's the closest we can get without going over. 16 is over. And we get 2. So it would be 3 2/4, which is, if you remember, 2 being half of 4, 3 1/2. So that's one way to do it. Another way to do it is a little bit harder, but it shows these equivalent fractions. We're going to have 14/4. We're going to pull out 4/4, and this is just subtraction if you don't like your division. 14/4 minus 4/4, which remember is 1 whole, gives me 10/4. Keep subtracting 1 whole until I get a proper. And there's my 1 whole again. Now, how many wholes do I have? I have 1, 2, 3 wholes and 2/4. 3 2/4, which, if you want to challenge yourself, is 3 1/2. So that's how they're getting to this 3 1/2 that they've shown here without actually showing you how to do it. That's how that problem is done. Another way to do this, and I just want to show you with the space I've got here, because if you look at the original problem, we have 4 3/4 and 1 1/4. Because this is the bigger number, and this fraction is also bigger than this fraction, you can just subtract the way we've done on the addition when we add it. So you can do 4 minus 1 is 3, and 3 minus 1 is 2/4. That's only going to work, though. It's not going to work on all the problems. It's only going to work when this fraction is also bigger than this. You can't mix up the fractions. They have to match with their whole number, so we can't just switch those around. But if this is already bigger than their second fraction, you can subtract that way. So that's another alternative for this type of problem. Now this is a little bit different because when I write this one out, 3 1/5, take away 2 2/5. Remember, these have to be together. We've got 1/5 here, and we've got 2/5 here. This is still the bigger number because the whole number here is greater. And I can't switch around. Those are not interchangeable. The associative property does not work for subtraction. So I can't do the same step that I showed you on the other one, but there is something else we can do here. Let me come back to this. I'm going to walk you through what the book has here before I show you another strategy, an alternative. So here we've got 3 1/5, which is our first mixed number here. And they're going to write it as an improper fraction in this box here. So we took 3 and wrote it as 1 plus 1 plus 1, which is also 5/5 plus 5/5 plus 5/5. And then we find the sum of those denominators are all the same. Pencil tool will work better. Nope. So we've got 5 as our denominator. 5, 10, 15, plus 1 more makes 16. And the pen hates me. There, can we do it? Yes, we can. Okay, 16/5. Now I've got 2 2/5. The 2/5 just comes over here. 2 is written as 1 plus 1, which is also 5/5 plus 5/5. 5 plus 5 is 10. 10 plus 2 is 12. Will it let me write today? Yes, it will. Yay! And our denominator is 5. So now I've got 16/5 is our improper fraction for 3 1/5. 12/5 is our improper fraction for 2 2/5. Now we're going to subtract those. 16/5 minus 12/5. 16 minus 12 is 4. And our denominator stays 5th. So 3 1/5 subtract 2 2/5 is going to get me 4/5. Now they're using addition to check, so they're taking these two fractions and adding them, opposite operation, to see if we get this fraction. That's what's happening down here. 4/5 plus 2 2/5, which is the same as 4/5 plus 1 plus 1 plus 2/5. So then they wrote 1 plus 1 is 2, 4/5 plus 2/5 is 6/5. So 2 plus 5/5 plus 1/5. 5/5 is 1, so that would be 2 plus 1 is 3. 3, and it decides to stop working. Let's try a different color. 3 1/5. Okay, that's the book way. Now here's my way. 3 1/5. We can go through writing all these out, or we can just pull out 1, because this 3 1/5 would also be equal to 2 5/5. So I've just pulled out 1, and I still have my 1/5. Mrs. Hildebrand, why did you write addition? We're doing subtraction. Because all of this here is just the same as this. And this is 3 1/5. So this is 2 and 1 plus 1/5. Make sense? So now I've got 2 and 5/5 plus 1/5, which equals 2 and 5 plus 1 is 6. 5 and 5 is my denominator, so that denominator is going to stay the same. Now all I've done is I've changed just this first fraction slightly. So now I've changed 3 1/5 to 2 6/5, which is still an improper fraction. But now it'll allow me to subtract from the 2/5. So now I've got converted 3 1/5 to 2 6/5. I'm going to subtract 2 2/5. And 2 subtract 2 is 0, which I don't actually need to write. 6 minus 2 is 4, and my denominator is 5. That's a little bit simpler, and that will get you the right answer. All you have to do, instead of decomposing this all the way down to the complete improper fraction, is make it a mixed number with an improper fraction. And then you'll still get the right answer with a few less steps. It's a cheating way. So there's that. In your guided practice, this one you can do just a simple subtraction fraction. Here is great. Number 2, you would have to start to decompose this because, as you can see, 1/3 is a smaller fraction than the 2/3 here. So I'm just going to get you started with that because it's kind of a fresh strategy. So we've got 6 and 1/3, subtract 2 and 2/3. I'm going to rewrite 6 and 1/3. Here's my thought bubble. 6 and 1/3 equals 5 and 1 and 1/3. And what is that 1? Well, it would also be 3/3. So that's going to be 5. 3 plus 1 is 4/3. So I would do 5 and 4/3, subtract 2 and 2/3. And I'm not going to give you that answer. You're going to give me that answer. So that's how those problems can be done. Now, this is tricky. So those of you who are in groups 1 and 2, those of you who are struggling with this type of math, I circled here 3, 5, 7, 8, 9, 10, 11. And the reason I circled those is because those are the ones I want you to do first. Those are the ones where the fraction is greater here than here. Ones you should be able to do using that first strategy that I showed you. Once you get through those, if your time is up, stop. That's fine. If your time is not up, then go through, watch the video again, look back at the webcam I gave for you, and try and solve some of these. These ones will, because the first fraction is smaller, you'll have to decompose it either partially or fully, like they showed you in the examples in the text. So that's these. I would strongly encourage those of you who are struggling with this to do the ones 3, 5, 7, 8, 9, 10, 11 first. And of course, I just checked through the problem solving, and all of them are going to involve decomposing those numbers because every single one, the first fraction, is smaller than the second one. So work on these. Maybe a lesson that when we get correcting it together for the video conference, this is something that we go over together because this is a big step. If you're working with your parents, you might have them try and give you different fractions there and see if you can solve just the word problem and write your sentence answer. That would be totally fine to get through these because these are, that was a steep learning curve on this lesson. Okay, hot problem, find the missing number. So if you go back in the video to where I showed you, or if you look at example, both of the examples had the addition. The first example would be fine. How to add these two up to figure out what your first part of the equation would be. Essential question, why should I use addition to check the answer to a subtraction problem? Well, the same reason you always check your work, right? First, you always do the opposite when you're checking, and you want to make sure that you've got the correct answer. You can go back and read your example problems to help you phrase it in your words. I'm going to run out of time. Again, if you get through this and you have time, go to the homework. If not, stop there. Don't overwork yourself. This will come up again and again. This is not the last time you will see these types of problems.